Hello everyone, welcome to this video. In this video, we will be discussing about the various types of database and the purpose of each of these. So if you look into this particular diagram, you see like at a high level, we have a database and we divided into three different buckets. First, we have this OLTP, which is online transactional processing. And we have a OLAP, which is again online analytical processing. And we do have the other category. So the difference is that let's assume that you are working for a retail corporation, something like a Walmart or a Target. So when a customer comes to the store and purchase something, that is a transaction. So that transaction will be stored in the OLTP. At the end of the month, you wanted to know how many of these items are sold. Then you will be using the OLAP. The other category, there are various products that we have. For instance, somebody goes to walmart.com and look for a product. At the time, we will be using the search. Also, each category has its own subcategory. For instance, if you see, the OLTP has relational and NoSQL. Likewise, the warehouse has Databricks of Fabric and Pure Warehouse. Others are plenty of others. So now let's deep dive into the difference between all of these. First, we will be focusing on OLTP. So now let's focus on the difference between relational and NoSQL. Let me go down. When you have multiple actors or elements work together in a system, then you will be using the relational database. For instance, let's say we are talking about a school, then we will be having the student, we will be having a teacher, we will be having the classroom and many other actors. So they all work together within the system, then you need a relational database. On the other hand, NoSQL will be focusing on a specific item. For instance, when we talk about the e-commerce portal, whenever you add item, that will get added into your cart. So the cart represents a single entity. Within the cart, you will be adding a number of products, but the cart itself, it's a single element. Now let's see how does it work. So if you see here, we can query against a single table, or we can query against a multiple table using join in relational database. Wherein in NoSQL, we will be working against a specific document. We will not be doing multiple joins. Join itself, it's not recommended with NoSQL. Again, we are not going to deep dive into any of these because it will take its own course for each of these topics. So now let's see how does the index or a partition key plays a major role. When you insert a record into the table, over the period of time, the order will be very unpredictable, and that is when you need an index. So if you see the index it's a map. So basically you will say, hey, this is my indexing column. So based on the column that you selected, what it will do is that it will capture all the record ID for the given company ID. And the order of the index, it's always predictable. So when you write a query and say hey, find all the information where the company ID is 18, it will go to the index and identify all the record ID and fetch all the relevant information for you. That would be a lot simpler than going into the table, scanning through all the records one after another and try to get the information. Now we will see how do we achieve the indexing in NoSQL. So basically it is done through the partition. So if you just come over here, so we create a container called reviews, and we are using the product ID as the partition key. So based on the partition key, the items are physically arranged. If you see here, we have a number of products: phones, car, book, cloth, laptop, or whatever is that. Each of these products will have its own physical location so that we can store the relevant reviews. See here, this is the simplified hierarchy of a Cosmos database. So you will have a database account. Within that, you will be creating a database. So here we call it as a retail. Underneath, we will be creating the containers, which is an actual database. And then there is going to be a physical partition and logical partition. So physical partition, it is handled by the Cosmos DB itself, wherein you will be using your partition key to create the logical partition. So if you see here, we are talking about multiple reviews. So each one will have the ID and product ID. So based on the product ID, we created the partition, right? And some other information like rating, comments, or whatever is that. So when you do a query, you can just say this is the partition key and pull up all the information. So this is going to fetch all the reviews. And if you wanted to fetch a specific review, then you can say, hey, this is the partition key and this is the ID. And recently Microsoft has introduced the hierarchical partition keys, which means that you can have multiple partition keys. So if you see here, like we have a tenant ID. Under the tenant ID, we are using the user ID, and under the user ID, we will be having the session ID. And if you wanted to do a query, then you can use all of these three to find out the exact partition and then like fetch the record. So depends on our specific needs, we have to choose the database. So if you are talking about a one specific element or a entity, then we can use a NoSQL. If you're talking about multiple actors, elements, items, then we can use a relational. Specific to search, we can use a search engine, though like some of the relational database offers the search capability, but like there are product specific to search itself. And for product reporting or analytics, we can use the analytical store or warehouse. So far we have discussed a lot about the OLTP, and we do understand the difference between the relational and NoSQL database. Now with that understanding, we'll also try to understand the difference between OLTP and OLAP. We do know that OLTP, it's a transactional processing, that is a day-to-day operation, wherein like OLAP, the analytical processing, it's a reporting like monthly, weekly reporting or yearly reporting. It's all those reportings will be generated out of this OLAP. So if you see here, typically like we will be using the OLT transactional information, and like there will be a process called ETL or ELT, extract, transform, load, or extract, load and transform, using which we can pull the data from various OLTP sources and put it into OLAP. In OLAP, we will be also holding a huge amount of data, and like there will be a applications like Power BI, Tableau, or whatever is that is going to read this information and generate a report. At a high level, if you do the comparison, OLTP meant for the transactional data, wherein like OLAP it's meant for the aggregated or a historical data. So the OLTP, it's milliseconds, like you place an order within couple of milliseconds, you should be able to respond back to the user. But the OLAP, it will take a couple of minutes to pull all this information and create a dashboard. And OLTP meant for data manipulation, wherein like this is optimized only for the queries. So if you see here, like there is a e-commerce application that will send the data to OLTP, like there will be multiple sources. So some will be relational database, or some will be CSV format, some will be in a different format, right? So all these are sources, and then like we will be using an ETL process, load the data into OLAP, and then like there are various people. There may be a data scientist, analytics engineer, BA user. All of these people will be using this OLAP platform to read the information. And if you look into this particular diagram, it is very evident that the OLTP, it's a single resource. Like you will have only a database, right? Be it SQL, Postgres, or NoSQL database, whatever is that, it is just going to be a single resource. But if you look at here, the OLAP, it's a collection of resources, right? So you need to have a storage place to store this data, and there is going to be a process to read this information from your source system and push it into the storage. And the data scientist, analytics engineer should be able to read and interact with this data, and the Power BI, Tableau kind of a dashboard application need to fetch and display this information. If you see here, at least there are quite a few products that we see. So there is going to be ETL product, there is going to be a data warehouse, and there is going to be a notebook kind of a thing that the data scientist, analytics engineer will use it to interact with the data. And there are applications like Power BI and OLAP or a warehouse. So if you see here, there are at least the very known products are like Databricks, Fabric, Snowflake, and BigQuery. So each of these has its own pros and cons. So I'm not going to go in detail. Rather, like in this particular video, we will be covering the Databricks, transaction data, and online orders, inventory, loyalty, and whatever is that. So all of these will have its own place to store this information, and there is going to be a process involved that is going to read all of this information and move it to the OLAP. And then, like, there is going to be a bronze layer. So bronze layer, it's where like we will be keeping the raw data, like however we read, we will be storing it into the bronze. And like a silver, we do a bit of cleanup, and like a gold layer, it's a business ready. And finally, like, we can use it with the analytics platforms. So this is just one piece of it. If you see it on the other side, the gold data can be used for machine learning or some other analytical purposes, right? But like at a high level, this is what we will have in OLAP. So again, like in this video, we will be focusing more on Azure Databricks. So first we will try to understand the internals of Azure Databricks. So it follows the pattern called the medallion pipeline. So let's assume that you have various data source, and like there is going to be ETL process. You will have a something called a Unity catalog. So basically think of this way, like a Unity catalog, it's kind of a SQL server. Underneath you will have various layers like bronze, silver and gold. These are all kind of a different tables. So first you will have the raw data coming in from your data source through your ETL process. And there is going to be a database server. It will have three different tables, bronze, silver and gold. And you will be using notebooks to read this incoming data and store the data into the bronze layer, and again use the notebooks to process the data and clean the data into the silver layer. And finally you will use the same notebook to move the data into the gold layer. And the data we interact with these information so that we can build various dashboards in Power BI. And at a high level, if you see in the Azure Databricks, we will have a data lake. So data lake, it's kind of a storage wherein like you can store your raw files or processed files. And the Unity catalog, that is going to be like where you will create your schema and manage permission and all of those. Again, this is pretty similar to your database server itself. And then a Spark, you need Spark compute. Again, like if you see here in all of these layers, we will be interacting with the data file, right? So to read these data file and process the data file, you need a compute. So this entire section, to process this entire section, you need a compute, and that is where you need a Spark compute. Databricks will be using Spark to read and process this data, and you need to have a compute, right? And the notebooks, this is how you will interact with the data. Say like you have a data file and you want to say, hey, like read this data file, you have to write something, right? And to do that, you will be using these notebooks. And once the data is finally ready, available in the gold data layer, and so the overall flow in Azure Databricks, it will be like this. So we will have a data source. We will use the notebook to read the data from the data source, which will make use of this Spark compute. And once the data it's processed, we wanted to store, then we will be using the data lake to store the processed data. And finally, the business applications will be using the Azure SQL warehouse to read the data from the data lake. So at a high level, if you see the Azure Databricks, this is what we will have. We will have an individual workspace per environment and per product. And within the workspace, we will have a Unity catalog. Consider this as a kind of a SQL server, and underneath you will have the dedicated tables, right? And using the Unity catalog, you can control the permissions, and you can apply policies or whatever you want to do it. And in order to execute the notebook and the SQL queries, you need a computing power that will also be there. Like there is going to be a all-purpose cluster, job cluster, SQL warehouse, and serverless. So these are the options that you will have under the compute. And in order to make the changes, or in order to interact with the data, you need to have the notebooks and SQL editor, and you can also schedule the execution. Say like you created a notebook that reads the data from the storage, and it does process the data, store it into bronze, silver and gold. then you can schedule that job. So every single day the job will execute. Finally, you can also integrate with repos, like whatever the change that you make in your notebook, that can also be stored in GitHub repositories. And underneath, if you see here, like the data lake, it's backed by the ADLS, which is nothing but Azure storage account. So you first create a storage account, and like on top of that you will have your data lake. Let me walk you through a demo. So for this particular demo, this is what we are going to do. So we will be using the credit application, like we have a couple of records in the CSV file. So I will be uploading the CSV file in the Azure storage. So we go to the Databricks, we will read the CSV file using the notebook. As we are using the notebook, we need to have a compute. So I will show you like how do we create a compute. And then like using this notebook, we will read the data and pass it to a bronze table, and then like we will clean the data and send it to silver table. From silver table we will apply the business logic and save it into the gold table. And then like finally we will have another notebook using which we will read the content from the gold table and push it into SQL Server. This step it's not needed. You can very well use the SQL warehouse here and pass it to the Power BI. But like in some cases we do not use the SQL warehouse, rather like the data will be directly passed to the SQL Server. Like we will have a Power BI gateway using which the Power BI can interact with a SQL Server and display the dashboard. So let's go to the Azure portal. So if you see here, like I have created a storage account in which like I have a couple of containers here. So I have the landing container, and like for each of these categories I do have a separate container, bronze, gold and silver. So there are separate containers. So, and if you see inside the landing container, I have a folder called credit application, in which I have a subfolder called inbound, in which like I have the CSV file. So this is the structure typically like the enterprise will follow. So you will have a root container, underneath you will have a specific application specific folder, underneath you will have a inbound, outbound and all those kind of folders. So typically like the file will land in the inbound folder, and that's how like we have the CSV file. This CSV file, it's manually created for a demo purposes. It does not have a lot of information. If you see this file, it has only 5 different records. So what it has is that application ID, customer ID, application date. So basically it represents the loan information. So the customer is coming to the bank and applying for a loan, whether the loan is approved or not, it's what captured here. It also has customer age, employment status, their income, loan they wanted, their credit score, existing debt, loan purpose, whether it is approved or not. So all of these information are captured here. And if you see the other container, so typically like it will be empty, but like I executed the flow, and that's why you see the files here. So in this file, in the bronze container, if you see here, we have 2 different kind of files. One is the log file, and like this is the data file. It's called a perk file. So we do have both the log file and the perq file. So same in the silver container. So in the silver container, so in the bronze container, we will be just storing the raw data as is. Remember, like whatever the information that we have in the CSV, that will be stored as a table in the perq file here. But in the silver layer, what we do is that we will segregate, like we will try to clean the data. If some of the data cannot be cleaned, we will reject the data. We do not want to pass the data to the next layer. So that's why like you see 2 different subfolders here, cleaned and rejected. Cleans, which means that whatever we get it from CSV file, that is sent to the bronze, that has been cleaned. If we think that hey, some of these record cannot be cleaned, that cannot be used for a dashboard, then we have to reject that. So that's what we have it here. And in the final gold layer, we apply a business logic, and that is where you see a different use case, right? So we wanted to know like what is the channel performance, what is the risk based summary, what is the overall approval summary. So all of this information, right? So each one represents its own unique dashboard, right? So we do have these separate folders for all of this, and if you go there, you will see the same thing. Like you will see the log file as well as you will see the perk file, like the data file here. Now if I go to the Azure Databricks, so creating a Databricks in Azure, it's pretty easy. You just go to the portal and create a Azure Databricks. So when you create a Databricks, this is what it will look like. This is the workspace. For each environment, you will have your own workspace, right? It depends, like some corporations will be using folder based execution for dev, QA and pre-prod, prod, or whatever the environment they have. But in general, like the typically what we do is that for each environment you will have your own namespace. Just for a demo purposes, I have only one workspace here, but think of this way, like this is Databricks demo dev, Databricks demo QA, Databricks demo, whatever the environment that you wanted to have it, right? So you will have a number of workspaces here, and under the workspace what we have done is that we have created a folder. So if you just come to that particular folder, there are quite a few things that you can do. One of the options that I wanted to showcase here, it's like a Git integration. You can click on that. If you have any Git repository, like there are a number of providers are supported, you can choose whatever the provider that you are using to safeguard your file. In my case, like I have opted for a Git repo, right? So I provided this information, and that's how I created a subfolder called Databricks, in which like I have created two files. Like again, like if I go back here, so there are two notebooks that we are talking about. The very first notebook, it will read the log file and does all of this, updates the SQL server, right? So now again going back, so I do have two different notebooks here. So if you go to the GitHub, you will see all these files here, and if you see, like there are two commits. If you just click on this, you will see like all the commits that has been done. So I created initial commit and I updated some information here. So how do we do that? Again, like if you just come over here where like you will see the branch that you are currently in, you just click here. If there are any modification done, then you will see it here, and then like you provide some comment, and then like do a commit and push. That's how we can do, right? And if you want to change the branch also, everything can be done from here itself. So just click here. I have only main branch, and that's why you don't see anything. But if at all you wanted to create a branch, you can create a branch and push it to that branch. You can also pull it from the main branch. So everything, like whatever you do in GitHub, you can very well do it here as well. So now again, like now in order to run these notebooks, so before we do it, I also wanted to showcase the catalog. If I just come over here, click on this catalog, you will see all the existing catalogs. So I have created a catalog called credit demo. So think of this way, credit demo, it's basically your database, right? Underneath, like you will create a number of tables. So I do have the bronze and then like a gold and silver. So everything is done through the code. I will quickly show you that. But if at all you wanted to manage anything database, then you can very well do it from here. Next, like we have this compute. So if you see here, I do have this all-purpose compute, which we already discussed, right? We already discussed about all-purpose job compute, everything we discussed. So we can quickly create one. I did create one. So if you just click on this, you will see all this information. This is the name of that policy, and then like what is the environment, what is the Databricks runtime, what is the server node you wanted to use it, right? I don't want to use a big one, so this is a very simple one. And then like if you see here, if you do not use this node for 20 minutes, it will get terminated. You can also terminate here, but typically like this is how like enterprise level we will do it. Now we do have this compute. So what we want to do is that we will quickly wanted to open this notebook. So how do we open the notebook? So you just go to the workspace, you navigate to the folder that you are working on. So just come over here, click on this, it will open the notebook for you. So this is how it will look like, right? So what we have done is that we have created the storage account and the storage key. We need both. If you just come to the storage here, where like you can get the storage keys, right? So if you just expand this one, you from where like you can get the storage keys. You need both the storage name and the storage keys. When you have it, you just come over, create those information here. Storage account. Now read the CSV file. So this is and like we create the catalog, and like we display all the tables within that. And the first step that we do in bronze layer, it's to read the CSV file and display the CSV file. And the we add some additional metadata. So basically like ingestion times and the file path, file name, size, whatever is that, whatever the metadata that you wanted to have, you can add it here. Then we create a delta table. When you create a delta table, what it will do is that it will store that information here. And if you see it here, you can see the sample data here. So select the compute. So start the compute. It will take about a minute to start the instance. So once it is started, then you will see the records here. Now again going back. So what we do is that we just display the table, and this is how you read the database name and the table name. You just display it here, right? And the what we can do is that you can also do a describe, so that is going to tell a lot about the table itself. And you can also save the file as a data file. So in this step, what we have done is that we saved the data as a delta table. So now what we are saying here is that we are saving this file as a delta file. So the difference is that when you do this, then the data will be stored in the Azure storage. So when you create this catalog, you will have a option to use the default location. So if you see here, this is the default location, but you will also have the option to choose the location where you want to store the file. In this case, I opted for a default, and that's why it is stored in the default file location. And if at all I wanted to store the data file in my storage account, then I can save it as a data file. That's what has been done. So I showed you both the option, right? So you can save it as a data file as well as a data table. Both can be done. So if you go back to the document here, you see right in the bronze, we just store the raw data along with some metadata. But in the silver table, we take the input from the bronze table, we clean and validate, and if some of the records doesn't match, then probably we have to remove those records from the data set. So that's what we will be doing in the silver layer. So if you see here, we are just creating a data frame, silver data frame using the bronze data frame, and we apply some transformation. So if you see we have the application date, we are changing that to a date format, customer age to a integer format, income to a double format, loan amount to a double format. So likewise, for how many ever columns that you have, you will be changing the column types. Then we will add some additional calculated columns based on the existing values. So if you see here, debt to income ratio, so we apply some business condition, business formula, based on which we will calculate some of these values. Same for how many ever calculated columns that you wanted to have based on the existing data, you will be adding those here. And we will apply some filters here. So this is based on the business condition again. So we wanted to make sure some of these columns must have the values. If not, these data cannot be used for analytics purposes. So this is why we will be creating the valid data and the clean data. The rejected data set based on this valid data set with the original data set. So we do have the original data set and we do have the valid data set. Based on that, we calculate the rejected data set. And finally, we will save it as a delta table. So if you see here, we are saving it as a delta table, as well as we save it as a delta file. So then finally we go to the gold layer. In the gold layer, we create the tables that answers the business questions. So if you just go back to the document again, so here we create some summary table, right? Remember, we are working with the credit application data set. So as a business, they wanted to know what is the summary, how many people applied, how much approved, and then they wanted to know what is the channel performed well. So in this case, the channels will be mobile, online, and the branch, and the who gets the approval, right? So we need to create the tables in the gold layer that answers all of these questions. So now again go back. So if you see here, we create the tables that will exactly answer the business question. So first we create the application summary table, and then we also create a channel performance, and finally we also create the risk band summary. So now we have all of this information. We can display this information so that we can make sure everything it's as per the business expect. So what we have done in this notebook is that we read the data from the Azure storage in the form of CSV, load it into the bronze, and cleaned and saved it into the silver file, and applied the business logic and created the gold layer. Now let's again go back to the document again. So we have covered all of these in notebook 1, and we need to work on notebook 2. So in notebook 2, whatever the table that we created in the gold, that needs to be read, and the data needs to be sent to the SQL server, so that the Power BI can use the data to display it. So now let's go back to notebook 2. So this is notebook 2. So again, we are just using the same storage account. So we have created the data files in the storage account. We are just going to read the same data file that we created in the gold layer. So that's what we have done here, and we just display the same information here, and we will connect with the SQL server. So we have created a SQL server. I will quickly show you that. So we connected with that SQL server. So here for demo purposes, I'm just using the basic connection, but in enterprise level you will not be using this kind of approach. But anyway, we are just connecting with the SQL server, and whatever the data that we have, we just push it into a specific table called credit application summary table. I did it only for one specific table, but then you will be doing it for all the tables. Now let me go to the SQL server. So if I just come over here, whatever the data that we published in SQL server, that you can query it here, right? So you will see all this information here. Now what we want to do is that again go back to the document. Now the data it's in SQL server, all we need to do is that create a Power BI gateway and use it in the Power BI. So now let's go to the Power BI. You can create the VNet gateway. Again, this is not a need, but typically this is how the enterprise will create, right? So if the data resides in on-prem, then you will be creating the on-prem gateway. If a data resides in Azure, then you will be creating the virtual network gateway. In my case, it is in the Azure, so I created a virtual network gateway, right? Now we can go to the Power BI and create a report, something like this, and publish it and access it. So this is how the business will be accessing your reports. Again, go back to the document here. So what we have done so far, we just had the CSV file using the notebook. We created all these layers and push it into SQL server and publish it into Power BI. So this is one approach, but sometimes, right, so they will not be using this SQL server, rather here instead of SQL server they will be using the SQL server warehouse, so that you do not need this notebook too. Rather with this the gold layer, everything is done. You just use this configuration to create this SQL server warehouse. I will quickly show you that as well. So if you just come over here in SQL server warehouse, you can create your SQL server warehouse, so that you do not need to send the data to separate a SQL server or any other database externally. Rather, the data file can still be within the Databricks itself, and you will be using the SQL warehouse to interact with that particular data from the external system, something like a Power BI. Now again, finally we can also create something like jobs and pipelines, right? So if you just come over here, click on this jobs and pipelines. So if you click here, you can create the pipelines. So if you see here, there are three options: one, ingestion pipeline, ETL pipeline, and job. So ingestion pipeline, so basically reading this information from the external system and pushing into the bronze layer or into a common place, right? And the ETL pipeline will make use of this ingest data to create the additional layers. So call it as a bronze layer or silver layer, gold layer. All of this will be done in the ETL pipeline. Job is the one that will stitch together, right? So it will add, first it will call the ingestion pipeline to pull the data, and it will call the ETL pipeline to process this data. So you can schedule the job, right? So that is how everything will be automated. You really don't have to do anything. So you just need to first set up everything, your ingestion pipeline and ETL pipeline, and configure your job, and like based on the configuration it will run as per the schedule, and it will populate the data as per your needs. So finally we will also discuss about the difference between Databricks and the Fabric. So if you see here, Databricks, it's a third-party application. However, Fabric, it's owned by Microsoft, which means that the Databricks can be operated not only in Microsoft environment but in GCP, AWS, or any other cloud platform. But this one, it's restricted to Microsoft platform. Storage, it does not come up with its own storage. You need to create your own storage for this. However, it has its own storage. Power BI, it's an external system. You can use Power BI, Tableau, or any other tools that you wanted to have it. However, it comes with the Power BI. When it comes to the cost, here you will create your compute and the DPU based pricing. However, it's a SKU based pricing.